Hello everyone, welcome to the class of Econometrics 1, Econ 331. This is lecture number 16 and in this lecture we are going to study about the goodness of fit of regression using Microsoft Excel.
In the previous session, we studied how to derive the values of beta 1 and beta naught, and we calculated them. Today we are going to progress a bit forward, and in today's lecture or in today's session, our objective is to learn about the estimated line, the regression line that for which we have found the values of beta naught and beta 1, and then we are going to proceed and find the residual sum of square and discuss the plot of the residual sum of square, and then we will move on to the r square and the importance of r square, why we need r square. So in order to do that, let us first find the values of y hat. Y hat is basically the values of estimated y, that is the estimated consumption. We have already got the values of y over here, but we need to find our estimated line, and definitely the estimated line will be different from the original values because the estimated line uses the slope that is beta 1, and also it uses the intercept, the beta naught. A straight line equation is basically y is equal to a plus bx, and a, or we can say y is equal to beta naught plus beta 1x. So beta naught is 14.63. We will use formula is equal to G28, and we are also going to fix the values of G28. So I have fixed the value of G28. Then according to formula, beta naught plus beta 1, and here is the value of beta 1, then multiplied, we use steric for multiplication, multiplied by the value of x. So we are basically estimating y for each value of x, and again I have to make the value of beta 1 constant because it remains in a single cell, whereas the value of x will change with each and every formula. And then I press enter, and I get the estimated value of y, that is 161, whereas the original value of y was 163. So this is what we have predicted for a given value of y, and it is obviously very close to the original value. And then again I drag the formula for all these cells, and what I get is a predicted value of y for each value of x. So when x is equal to 214, our prediction of the value of y is 145, whereas the actual value is 149. Then when the value is 213, our prediction is 144, whereas the actual value was 142. There is a slight difference in each value, and this is what we call the residual term. This is the residual, and we can graph the y hat value. This is our y hat. I should select all the values of y hat and then go on to insert. When I click on insert, I click on the 2D line curve, and okay, for I also need to select the value of x for this purpose, so that the line curve is I think I should move on to the scatter plot that will give me a better result. It is the scatter plot, and if you look at the scatter plot, it is a straight line, and basically I can also change the layout from here. I can use the functional form, so it can give me the equation as well, that is y is equal to 0.611, 14.63 is the slope. So this is my regression equation, the line for regression equation. And I may also change the axis title. For this purpose, I write this as our income, and on the y-axis I change the label by double clicking and deleting the all values. This is basically the consumption. So this is our estimated y height, and this is our straight line equation, and I can use a number of formats if I want to, but I think this is good enough for me. This can do the job for me. Okay, let me move it to this side so that we can work on more things over here. We can use this graph and copy it to Microsoft Word in case I am doing any research work. Next is we want to find the residuals. So this is our, I've written residual over here, and I want to calculate the residuals. So basically a residual is the difference between the actual value of y minus the estimated value of y, and that is the difference between the two is 1.67, and again I copy this for the entire sheet and I get the residuals for all the values of x, for all corresponding values of x. Let us also find a summation for this. So equal to sum, and I selected all the residuals and press enter, and I also need to adjust the values to remove the decimal places. So format, I choose the format cells over here, number and 2 decimal places. Press OK. So you see this is now a readable version of it. We can do it for the rest of the values as well, so that they can easily be readable. Format cell, and it's a number with 2 decimal places, and press OK. So now look at the summation of the residual. The summation of residual equals 0, and this is the property of a regression line, that whenever we sum up the residuals, its sum will always equal to 0. Therefore, when we want to find the r square, we convert it to the residual sum of square format, so that we can use our calculation, or even when we are calculating, we are deriving the formulas for beta naught and beta 1. In that case, again we convert the residual into their square formats, so that we can avoid this problem of zero sum. So let us begin into the residual term and see how it behaves when the value of x changes. So for that purpose, I select the residual terms, and then I also select the disposable income, Keep it in mind that when you are selecting two rows, you should keep the control button pressed so that when you lift the mouse key up, you still are able to select further cells along with it. Then I move on to the insert, and in the insert section I click on the scatter plots, and then I graph the scatter plot, and this is the scatter plot for my residual terms. Let me change its color so that it is visible. Let me choose a darker background. Okay, this one looks good. These circles, these show our plots, our residuals. Now look at the mean value. The mean value of the residual is the property of the residual term that is always 0. And the residuals will lie above and below the mean value, again in such an order that when you sum up all of these residual terminologies, these residuals, you will get a sum equal to 0, and that is what we have discussed a little while ago, that the summation of the residual term is always equal to 0. Now there is another interesting thing that we need to look at the residual scatter plot, that is how is its behavior when we increase the value of x. So apparently we see that they are equally distant from the midline, that is the 0 line. In some cases we may see that as we progress with x, the distance between the midline and the values of these residual, that increases. So that can identify the problem of heteroscedasticity. Basically, heteroscedasticity means that the variation of the residual term is not constant over the values of x. In this case, the value of the residual terms that is constant when we are increasing x. So we do not see any huge variation. Again, the residual plot is important in understanding autocorrelation. In autocorrelation, we may see that the residual term is either alternating, or there is an increase or some of the values of the residual terms are positive, then suddenly they move on to the negative quadrant, and then again they move on to the positive quadrant. So that can give us the problems of autocorrelation. And normally, if we are talking about heteroscedasticity, heteroscedasticity is usually related to the cross-sectional data. But if we have time series data, we may be able to identify the autocorrelation through this graph. So that's why plotting a residual is sometimes important whenever we run a regression equation. Next, we are interested in finding the goodness of fit, whether the model that we have estimated is a fit model or not, and for that purpose we usually require the residual sum of square. We also require the total sum of square and explain sum of square, and if we have two of these three, we can easily find the R square value, and R square is a goodness of fit measure. So let us find the residual sum of square, which is relatively very easy, and I write RSS to identify the residual sum of square. Then I square up all the residuals and I drag the formula. So I've found all of these residuals, and another important thing is I want them to look decent. So again I format the cells, format cells, and convert this into number with 2 decimal places. Okay, So it now looks a bit decent. Now you can see two observations over here that have the value above 100, even above 200. Otherwise the remaining residual sum of square values are less than 200. Basically there is what residual sum of square do is it magnifies the residuals. So if you look at these two extreme values, the one is 15 and the other one is minus 15, we are getting a higher residual sum of square for these two values, and that is what squaring does to the values of the residual sum of square, to the value of residuals, sorry. So we have the residual sum of square, and the next thing is we are interested in the um, sorry, we need to find the residual sum of square down here because we haven't summed it up yet, we have only squared it up. So I have written the formula equal sum and bracket start, and now I have selected all the values and bracket close, enter. So the residual sum of square is 844, and then I also need the total sum of square, and we define total sum of square as the difference between the actual value of y and the average value of y, and that is y minus y bar, and its summation is basically the total variation, not only its summation, but we need to square it first and then find its summation. So the total sum of square TSS is equal to, I write the formula, y minus y bar raised to the power 2. The head sign is used for powering up, and I press enter, and then I drag the formula for all the cells, and after doing I copy the summation formula so that I can find the sum for it. So this is our total sum of square, right? And then we can also find the value of explained sum of square, and explained sum of square is basically y hat minus y bar whole square. So ESS can be found as y hat is equal y hat minus y bar, and the value of y bar is over here, that is the average of y, the average value of consumption, and I have to fix it in all the formulas, so I put the dollar sign again. This is y hat minus y bar, so I close it in brackets. So when I take the square of it, the square applies on the whole value, and press enter and drag the formula down. Again I need to format it up to 2 decimal places, so I reduce the decimal spaces to 2 and press OK, and its summation is this summation gives us the total, the explained sum of square. Now we are able to find the value of r square, and basically r square can be calculated either by dividing explained sum of square over total sum of square, or by subtracting residual sum of square or total sum of square from 1. So both the formulas are correct. So let me do that. I want to calculate the value of r raised to power 2 r square equals to explained sum of square divided by total sum of square. So here we have explained sum of square divide by the total sum of square, and the value is 0.932766, or in short 0.93. Again, let's format it up to 2 decimal spaces. It's a number with 2 decimal space. So the residual sum of square, sorry, the r square is 0.93. Now alternate formula is 1 minus RSS or TSS. So 1 minus bracket start RSS divide by the value of TSS and bracket close, and again I get 0.93. So what is the basic logic behind? The basic logic is that the total sum of square is equal to explained sum of square by explained sum of square plus the residual sum of square. So we can find that this total sum of square is equal to the explained sum of square plus residual sum of square, and you see we get the identical result. So basically readjusting, we are finding the value of r square by readjusting using the same concept. So r square tells us how much variation is explained in this model, how much the values of x, if it is x1, x2, x3, whatever, how much of those changes in x can explain the overall changes in our model, and that is equal to 0.93, which is a very high value, and it is a very good model to predict, and the prediction power in this model is very high. That means that we can explain the changes in consumption if we are given the disposable income. But there are certain pitfalls in interpreting the value of r square. The first thing is that high r square does not mean that we have a very good model. It is not always true. The second, that it does not mean causation. High r square is only the correlation, and if we have only two variables such as x and y, then r square is the correlation between x and y. So the correlation between the consumption and disposable income is equal to 0.93. But if you have more than two variables, then it is not the correlation, but the overall influence of all the x variable with the y variable. Then again, low r square does not mean that we have a very bad model. In some cases, we may get low r square, but there may be causality, and that causality may matter a lot. It may be a very good explanator, but still we can get low r square. And in many cases we may get a higher r square that may represent multicollinearity, or we may also get higher square where two variables, these x and y, are actually not related with each other but with another common variable. So in that case we may also get higher r square. So one should be clear how to interpret the result of r square. If theoretically there is a relationship between consumption and disposable income, and there is a relation, then we can say that there is a high causality. Otherwise we cannot say there is a high causality between x and y based just on the value of r square. So I hope that was enough, and hope you have learned a lot from this session. Thank you very much.